Okay, so now we're on to kind of what we've been building to, which is graphing trig functions on our own. And so just as a quick reminder, when we do a cosine, the sine function and the cosine function, we had important things about both of them. The first is kind of our starting point for the two. For the sine function, when you have x equals 0, this is all going to be in radians, then you know you're going to start at this point. And then we know our period is 2 pi. And what we end up finding out is that there are 5 important points that we're always going to be looking at. And those are the ones that where it intersects the midline and then where it's at a max and a min. And so the way that because of the 5 points, that is 4 sections. And so finding out what your x scale and your y scale is always going to be important. So if we set our x scale as pi over 2, and our y scale as, we're going to say 2, then, not 2, 1/2. When we graph this, the first point 0, 0, and then at pi over 2, that's when the sine function is equal to 1. And so we just go to that point right there because each of our vertical lines right now represent a pi over 2 shift. And remember, our period is 2 pi. And so then we go here, and we go here, and we go here. And that's what our sine function looks like when we're doing one of these. And then our cosine function, and so the things we remember is it starts at 0, 0, and it goes up. And then it goes up to where it's at a 1, right? This is a 1, 0, negative 1. And then the cosine function is very similar, except instead of starting at 0, 0, you start at 0, 1. And you don't go up to start with, you go down. And it looks like this. And so what we're going to be doing is one of those two functions whenever we graph these. And then we're going to use everything we learned about period, about midline and amplitude to graph these. And eventually we'll add a third part into it. But for now, we don't have any of those where we are doing something inside the x. We haven't studied that yet. So our first example would be graph y equals 2 sine of pi x let's say minus 3. Okay, so if we remember what we have here, we had this means we have an amplitude of 2. And so when we're doing this, by the way, it probably makes a good sense then to kind of think about the way you want your graph to look. And so with an amplitude of 2, I'm just going to make my y scale equal to 1. Now, what you're going to notice is that this problem is going to end up looking very similar to the graph we just did, but we're going to scale our y-axis and x-axis in a way that allows us to graph it. Even if it looks the same as the previous graph, it all is going to be based upon what is your scale. And the scale is going to determine if you've graphed it right rather than necessarily the way the graph looks. And so then our period, well, remember our period is found by doing 2 pi over b, where b is the coefficient of x. And so we divide by pi, and we get a period of 2. And so that means whenever we do the x scale, we always want to just divide our period by 4 and make that our x scale. And so in this case, it's 1/2. And that way, this is going to be the first point that's going to matter. And then we're just going to move each line over to allow us to do that. So, and then the last thing is our midline is going to be y equals, it's always whatever is being added or subtracted to the sine or cosine function. And so in this case, it's negative 3. So when we look at this, we know our midline is going to be here. So our amplitude is going to be 2 above and 2 below that. Our first point is going to happen at 0, negative 3. And because our y scale is 1 and our amplitude is 2, our first point is going to go up 2 from there. Our next point is going to be here, and then here, and here. And that's what our graph's going to look like. If you have that's one period graph. If you're graphing by hand, I would want you to do at least 2 periods so you could tell that you have an idea of how these things continue on. And so that was what your graph would look like for this problem. Again, one of the most important part is making sure that you've properly scaled your X and your Y axes so that your graph can look the same. Most of our actual drawings will look the same. The scales will just be different, or they'll look very similar to each other. Okay, now just to make sure we're understanding what's happening, let's just, if we plug in a point, like let's plug in when X equals 3/2. So if X equals 3/2, we get Y equals 2 sine of 3/2 pi minus 3. Well, 3/2 pi, remember, on our is 270 degrees. And so sine at 270 degrees equals -1. And so we get Y equals 2 times -1 minus 3, which equals -5, which is exactly going to be this point right here, right? 3/2, -5 is on the graph. If we would have looked at, for example, when pi x equals 1/6, we'd have Y equals 2 sine of pi over 6 minus 3. Remember, pi over 6 looks like this, and so that is going to be a 1/2 is going to be the value of sine of pi over 6. And so you're going to get Y equals 2 times 1/2 minus 3, which equals -2. So at 1/6, it equals -2, which is exactly that point right there. So don't forget that plugging in values is going to give you this graph. And if you ever forget some of the things we're doing here, you can always fall back on plugging in values to figure out what the graph is, the basic idea of what the graph is going to look like. All right, let's do two other quick examples of these. If we've got Y equals 1/2 cosine of 2x plus 1. Okay, our amplitude is 1/2. And so if we want to make it at least so you go up 2 lines just so it's a little bit easier to draw, then you can make the Y scale would have to be 1/4. And so that means that each of these are 1/4, right? 1/4, 1/2, 3/4, 1, 5/4, and so on and so forth. And when I do that, I'm going to recognize that's going to actually put me up too high because the midline is going to be 1, which means to be all the way up here. So I'm going to actually change this to just be 1/2 instead of 1/4 so that it makes it, I have more room in my graph. And then the X scale, well, our period is going to be 2 pi over 2, which is pi. So when I divide that by 4, my X scale is going to be pi over 4. And so this is going to be pi over 4, pi over 2, 3 pi over 4, pi, and so on and so forth. All right, it's a cosine graph, and so it starts at the amplitude, the maximum point on the midline. The midline is 1, Y equals 1. So here's, since I made my Y scale 1/2, here's your midline. So the first point we're going to do is 1 above that, because or 1/2 above that. And so it's actually going to be right here because if you remember, we changed our Y scale to 1/2. And so then it's just going to go like this. So our graph looks like that. Or like that. And so that's the graph of Y equals 1/2 times cosine of 2x plus 1. All right, last one here. If we look at Y equals let's say Y equals 4 sine of pi over 3x, and then asked to find this. Well, this is one where there's nothing being added to it, so our midline is 0, so we're just midline, which is going to be the origin. Our amplitude is going to be 4. And so since our amplitude was 4, we can make our Y scale 1, or we can make our Y scale 2. Let's just make our Y scale 1 for this one since we're at the midline of 0. Our period is going to be 2 pi over 3, which equals 6. And so since our period is 6, If we divide that by 4, then we'd be doing each of these an x scale of 1, or of 3 halves, which you could do if you wanted. But if you don't want to do 3 halves, which is kind of an odd one to make the scale, you could just do 1. So if we made the x scale of 1, then we'd have 0, 1, 2, 3, 4, 5, 6. If you did it like that, then the maximum point is going to happen at 3 halves, and then the back to 0 is going to be at 3, and then 4.5, and then 6. Or you could, again, made the 6 scale 3 halves and graphed it that way. It's sine, so it starts at 0, 0. So here's our first point. Since I did x scale of 1, then we've got a max, an amplitude of 4, so a max of 4. It's going to go here, and then down to here, and then down to here, and then back to here at 6, wherever that point would be. And so it looks something like this. And then you could go back at these points. Should be 3 right there, yeah. Okay. So graphing 2 periods of the function would look like that.